Hello everyone. Today I am going to discuss various criteria that help in defining a clean modular architecture for a software system. So basically it belongs to the design concepts on chapter number 5. Let us start with the design concepts. Software design usually involves problem solving and planning a software solution. Every software process is characterized by basic concepts along with certain practices or methods. Methods represent the manner through which the concepts are applied. As new technology replaces older technology, many changes occur in the methods that are used to apply the concepts for the development of software. A set of fundamental software design concepts has evolved over the history of software engineering. Although the degree of interest in these concepts has varied over the years, each has stood the test of time. Each provides the software designer with a foundation from which more sophisticated design methods can be applied. Each helps you define criteria that can be used to partition software into individual components, separate or data structure detail from a conceptual representation of the software, and establish uniform criteria that define the technical quality of a software design. The design concepts provide a software designer with a foundation from which more sophisticated methods can be applied. The fundamental concepts underlining the software design process remain the same, some of which are described here, like we can say the abstraction, architecture, then patterns, separation of concerns, modularity, information hiding, refracting, structural partitioning, refinement, etc. Now the next one, that is the patterns. A pattern provides a description of the solution to a recurring design problem of some specific domain in such a way that the solution can be used again and again. The objective of each pattern is to provide an insight to a designer who can determine the following things, like whether the pattern can be reused, whether the pattern can be used to develop a similar but functionally or structurally different design pattern, whether the pattern is applicable to the current project. Software engineer can use the design patterns during the entire software design process. Brad Appleton defines a design pattern as: pattern is a name nugget of insight which conveys the essence of a proven solution to a recurring problem within a certain context amidst competing concerns. The design pattern describes a design structure that solves a particular design problem within a specific context and aimed forces that may have an impact on the manner in which the pattern is applied and it is used. So, for the intent of each design pattern is to provide a description that enables a designer to determine the following things, like whether the pattern is applicable to the current work, whether the pattern can serve as a guide for the developing a similar but functionally or structurally different patterns, whether the pattern can be reused, hence saving design time. Now, what is exactly the separation of concerns? Separation of concerns is a design concept for separating a computer program into distinct sections such that each section addresses a separate concern. A concern is a set of information that affects the code of computer program. The overall goal of separation of concern is to establish a well organized system where each part fulfills A meaningful and intuitive rule, um, basically we can say it's a role, while maximizing its ability to adapt to change. Separation of concern is a design concept that suggests that any complex problem can be more easily handled if it is subdivided into pieces that can each be solved and or optimized independently. A concern is a feature or a behavior that is specified as a part of requirements model for the software. By separating concerns into smaller and therefore more manageable pieces, a problem takes less efforts and time to solve. It follows that the perceived complexity of two problems when they are combined is often greater than the sum of perceived complexity when each is taken separately. This leads to a divide and conquer strategies. It's easier to solve a complex problem when you break it into manageable pieces. This has important implications which regards to software modularity. Separation of concern is manifested in other related design concepts such as modularity, aspects, functional independence, and refinement. Now, let us see what is the information hiding in the design concept. So, information hiding is a fundamental design concept for software. The principle of information hiding suggests that modules be characterized by design decisions that hides from all others. In other words, modules should be specified and designed so that information or the algorithms and the data contained within a module is inaccessible to other modules that have no need for such a information. So modules be characterized by the design decisions that hides from all others. Hiding implies that the effective modularity can be achieved by defining a set of independent modules that communicate with one another only that the information that is necessary to achieve the software functions, because most data procedures are hidden from other parts of software. The inadvertent errors introduced during modification are less likely to propagate to other locations within the software. Modules should be specified and designed in such a way that the data structures and processing details of one module are not accessible to other modules. They pass only that much information to each other which is required to accomplish the software functions. The way of hiding unnecessary details is referred to as information hiding. IEEE defines information hiding as the technique of encapsulating software design decision in modules in such a way that the module's interfaces reveal as little as possible about the module's inner workings. Thus, each module is a black box to the other module in the system. The module should be specified and designed in such a way that the data structures and processing details of one module are not accessible to other modules. They pass only that much information to others, which is required to accomplish the software function. So, this is the information hiding. Now, the next one, that is functional independence in the software design concept. In software design, the concept of functional independence is a direct outgrowth of separation of concern, modularity, and the concept of abstraction and information hiding. The functional independence is defined as a direct improvement or enhancement to the concepts modularity, abstraction, and information hiding. The functional independence can achieved by developing the modules for their single isolated respective functions and then combine these modules through interacting approaches to achieve objective or goal. Functional independence is achieved by developing modules with single-minded function and an aversion to excessive interaction with other modules. Stated in other way, we want to design software so that each module addresses a specific sub-function of requirements and has a simple interface when viewed from other part of the program structure. Independence is important because software with effective modularity, that is independent module, is easier to develop because functions may be compartmentalized and interfaces are simplified. Independent modules are easier to maintain because secondary effects caused by design or code modification are limited. Error progression are reduced and reusable modules are possible. Hence, the functional independence is a key to good design, and the design is the key to software quality. Independence is accessed using two qualitative criteria. So, the first one, that is cohesion. Cohesion is an indication of relative function strength of a module. A cohesive module performs a single task requiring little interaction with other components in other parts of program. So cohesion is an indication of the relative functional strengths of a module. Then the second one, that is coupling. Coupling is an indication of the relative independence among modules. Coupling depends on the interface complexity between modules and the point at which entry or reference is made to module and what data passes across the interface. Now, what is the refinement? Stepwise refinement, also called as a top-down design, refers to the progressive refinement in small steps of a program specification into a program. Basically, the refinement is a process of elaboration. Refactoring simply means to reconstruct something in such a way that it does not affect the behavior or any other features. A hierarchy is developed by decomposing a macroscopic statement or function in a stepwise fashion until programming language statements are reached. So, we can say we can say the refactoring in a software design means to reconstruct the design to reduce and complexity and simply it without affecting the behavior or its functions. Follower has defined refactoring as the process of changing a software system in a way that it won't affect the behavior of design and improves the internal structure. This refinement is a top-down design strategy used for decomposing a system from a high level of abstraction into a more detailed level, that is a lower level of abstraction. At the highest level of abstraction, function or information is defined conceptually without providing any information about the internal working of the function or internal structure of the data. As we proceed towards the lower level of abstraction, more and more details are available. that is object oriented design concept. Nowadays, the object oriented paradigm is widely used in modern software engineering. Object oriented concepts are used in design methods such as classes, objects, polymorphism, then we can say inheritance, encapsulation, data hiding, or dynamic binding, interface, and so on. To understand object oriented analysis, the following concepts must be known. So the first one, that is the object. It is an instance of a class. It is used to describe the real world entity. Then the second one is a class. It is a collection of similar objects. For example, we can say the animal, that is a class, and the object, we can say the tiger, it's a object of a animal class. Then the next one is attribute. Attribute is a collection of data values which describes the state of an object. Then the next one, that is the operation. Operations are also known as method and service, provides a means to modify the state of a class. Then the next one, that is the inheritance. It is a process in which an object inherits some or more features of a superclass. Then the last one, that is polymorphism. It is an ability of an object to be used in more than one forms. The main advantage of object oriented design is that improving the software development and maintainability. So the main advantage of object oriented design is that improving the software development and maintainability. Also, it's one more advantage is that the faster and low cost development and creates high quality software. The disadvantage of object oriented design is that larger program size and it is not suitable for all types of programs. So the next one, that is persistence classes. It shows data stores that will persist behind the execution of the software. And the last one, that is the system classes. System classes implement software management and control functions that allow to operate and communicate in computing environment and outside world. And also one more, there is that is the design class characteristics. The characteristics of well formed designed class are as follows. Complete and sufficient. A design class must be total encapsulation of all attributes and methods which are required to exist for the class. Then the second one, that is the primitiveness. The method in the design class should fulfill one service for the class. If service is implemented with a method, then the class should not provide another way to fulfill some things. Then high cohesion and low coupling, that is discussed in previous session. So, cohesion design class has a small and focused set of responsibilities. For implementing the set of responsibilities, the design classes are applied we can say mindedly, single-mindedly to the methods and attributes. And the low coupling, that is, all the design classes should collaborate with each other in a design model. The minimum acceptable of collaboration must be kept in this model. If a design model is highly coupled, then the system is difficult to implement, to test, and to maintain over time. Thank you.